In this video, we are going to go over how to generate a geometric function rule for a geometric sequence. That's a really fancy way of saying, I'm going to give you a pattern that is a geometric sequence, and we're going to come up with, well, the pattern and the function that will allow us to find any number of the terms in that sequence. Let's dive in and see what we're dealing with. So instructions say write the function rule for each geometric sequence. Now I'm just giving you the overall general rule for it. Now if you haven't already watched it, check back in chapter 5 for the general rule for an arithmetic sequence so you can see where these terms a sub n and a sub 1 come from. Otherwise, this is the first time you're watching this, you might be looking at that like, what are these things? So a sub n is the nth term. That means that if it was a with like a little 4 underneath it, that would be, in this sequence, 1, 2, 3, the 4th term. A with that n being like a 5 would be the 5th term. A sub 1 means the first term in the sequence. R, we saw in a previous video, is the common ratio. That is the amount that we're multiplying every preceding term by again and again. N minus 1 is the number of terms we're multiplying by. So I'm actually going to use this and explain why this works with this first example. And then we're just going to use this to do letter B. All right, so we're again told to write the function rule for each geometric sequence. First thing I need to do is figure out what the common ratio is. What am I multiplying or dividing by each time? So 5 times 2, we're told it's geometric, so we know we're multiplying by a set number every time. Gives me 10. 10 times 2 gives me 20. 20 times 2 gives me 40. You also could have divided 40 by 20 to see that it was multiplied by 2, and 20 divided by 10 to see is multiplied by 2, and so on and so forth. So, if we look at the pattern here, what's happening is that we're starting out with 5, and we're repeatedly multiplying by 2, right? 5 times 2 is 10. If you multiply by 2 again, that's 5 times 2 times 2, that gives you 20. 5 times 2 times 2 times 2 gives you 40. Well, this is the 4th term, and this is the 1st term. So there have been 3 times that we've multiplied by 2, which would be the 4th term to the minus 1, right? Or to the 4 minus 1. And that makes sense. It's the number of spaces. If you're at the 4th term and we came at the 1st term, we had 3 times that we went from one number to another, which would be 2 times itself 3 times. Now take a look at the model. A sub 1 times, it's getting exciting, r to the n, whatever term you're at, minus 1. Minus 1 giving the number of spaces. And that will give you whatever term we wanted. In this case, it would have been a sub 4. That's it. So our overall rule in general then is a sub n equals our first term, which is 5, times r, which is 2, to the n minus 1. That will be our rule because then we can get any nth term, and I'll show you how. If we want, let's say, the 11th term, a sub 11. So what is the 11th number in that geometric sequence? I'd have to take 5 times 2 to the 11 minus 1, which makes sense. If we're going from the first term to the 11th term, there are 10 spaces. 10 times we'll be multiplying by 2, and that's what we get, 5 times 2 to the 10th. Ooh, and of course we'll simplify that out. That is 5,000, hopefully I'm doing this mental math right, 5,120 is your 11th term. That's it. That's why the geometric sequence makes so much sense. It's the number of times you're multiplying by the common ratio, which you're always multiplying by the original value by that common ratio, however many times. Sweet. Now we're just going to use it, all right, in letter B. Let's check it out. So letter B, well here, it looks like we're actually going down an amount and, well, it's becoming from positive to negative. So it looks like we went from here to here, and negative 18 over 54, you could use a calculator or your brain, that's dividing by negative 3, which is the same as multiplying by negative 1/3. From negative 18 to 6, that is division by negative 3, or multiplying by negative 1/3. 6 times negative 1/3 will give me, or dividing by negative 3 will give me negative 2. So now using our formula, we've got that the nth term is equal to the original value times r to the n minus 1. Well, we don't know what the nth term is, but the original value is 54 times, and I'm going to put this in parentheses, negative 1/3 is what we're repeatedly multiplying by. Sweet. and that's raised to the n minus 1. So now that's our function, that's it. So let's say I wanted to find, I don't know, the 7th term. A sub 7 equals 54 times negative 1/3 to the 7 minus 1, which is 54 times negative 1/3 all raised to the 6th. And when you do that math out, you end up with a positive number, and you get 2 over 27, which actually makes a lot of sense, because we'd take negative 1/3 of this, which would be positive 2/3, that's the 5th term. Then we would take, so that's positive 2/3, that's the 5th term. Then we'd multiply by negative 1/3, and that would give us the 6th term, which is negative 2/9. Then we multiply that by negative 1/3, which is positive 2/27. A little easier to get it there from the formula. So again, geometric sequences, it's all about figuring out what you're multiplying by in your common ratio, and then taking your original value and the common ratio and putting it into the general form of a geometric sequence. Watch the video again if you need a little help understanding why it is that this sequence fits with any geometric sequence. But it's got to be geometric. Has to be geometric. See you next time.